Greetings. This is a thought piece about driving quantified, statistically valid testing into the early stages of the product cycle. Typically, tests with statistical rigor are done in the deployment stage, like the big web companies have huge A/B testing operations to continually roll out and test new features. But when you look at typical QA, UAT testing before deployment, there's not a lot of statistical studies done there, and certainly even less in the design phase when you're working with paper prototypes and mock-ups and early artifacts. So this is about the concept of using high-res, fully functional HTML, CSS prototypes that can generate statistics and push them into a wide range of repositories and analytical and visual tools. Here we go. Couple caveats about what you're going to see. The data that's shown in these examples is real, but it's not customer data or company data. It's just data that we created with our own click flows. The goal is to share ideas and show possible direction towards innovation, but it's not really a full solution. And in an actual study, there would be a data scientist involved, hopefully, who would look at the study proposal and decide on the final study parameters. So with that said, here we go. To understand some of the intricacies of the post-production large-scale testing environment, we can look at Ron Cahovey, who ran personalization for Amazon and was basically a head quant at Airbnb and did some amazing things at Microsoft at scale. And he's in an environment where they typically can run a huge amount of experiments every week, working with millions of users. Each user can be exposed to multiple experiments, and then they have to sort of hold some of the users back as a comparison to see if there's any ill effects of the testing program. And basically, there's almost no single version of the app because there's so many variants, and they're keeping up to 1,000 data points or more for each user. Some of the things that Cahovey has caught in his A/B testing are minor, very small changes, but can add up to tens of millions of dollars or even hundreds of millions of dollars of revenue. If we wanted to use some of these techniques and approaches for early testing, some of it applies, but a lot of it doesn't. I mean, we obviously don't need this complex megalithic infrastructure. Also, the stats are somewhat different for small n testing, so there's that adjustment that needs to be made. And then in general, the test tools and the platform vendors are sort of chaotic right now, and there's a lot of them. And there's the danger of lock-in and reduced flexibility if you get entirely in bed with some of these. So they all have great features, but there's the question of how a design team can maintain flexibility. So on the stats aspect of this, we're really lucky because there is an enormous body of work. It's not necessarily widely known, and it's not necessarily just for small scale, but it does have a huge component of it, that's perfect for the design cycle, where you, in the formative stages, you're designing, you're testing, you're iterating. These guys, James Lewis, Jeff Sauro, Jacob Nielsen was a big part of this effort. They have a huge, wonderful body of work. You can see James Lewis alone has 21,000 citations for his publication. So there's books, there's papers, there's tools, there's R code, and it's largely applicable. Here's sort of a summary of Sauro and Lewis' approach, where they say you can quantify data from small sample sizes and use statistics to draw conclusions. They really blur the lines, I think, between qual and quant, because almost anything you do that's qual can be quantified. It can be counted, it can be analyzed statistically. Here's my way of thinking about this, which is cherry picking great techniques from ethnography, benchmarking, psychometrics, session capture, even tracking and A/B testing. And we're going to take all these things and make them work together with no vendor lock-in and at nice, small, manageable scales. So the way we do this is, if you imagine a screen, it could be a web app, a single page app, whatever, and we're going to make a high-res prototype that's HTML and clickable, but it's only a client-side instance. And then we're going to run a bunch of JavaScript and conditional logic in this prototype that can make REST calls and API calls to whatever we want. Rather than just running a code from some tool provider and relying on them 100%, we're going to push events into anybody we want, not just tool vendors, but also into our own repository, so we can analyze it anytime we want with the best analytical tools, Tableau, R, SPSS, Power BI, etc. I'm going to be using Piwik Pro, which is an open source repository, but this could be done with Snowflake, a variety of Amazon repositories, Databricks, Segment, etc. So here's a summary of what we're going to do. We're going to run a prototype and push API calls anytime any event happens, any buttons pushed, if there's a drag and drop, if there's opening and closing things. These will generate JavaScript calls that will go to MouseFlow and that will go to Piwik, the repo, and then we can pull up this raw data in Excel and massage it and look at it in R and even GPT. So here's the prototype. And imagine that you're a test subject. You've been invited to this link and you see some simple instructions here. There's a navigation system on the left that's got some reports in it, and then some of the reports are in folders that you can open up. So financials a folder, utilization's a folder. And we want to make a new folder. So create a new folder, name it, add a report to it, and exit. So the user would go into the settings and see that they can add a folder here. They can then name the folder. We'll call it my new folder. They could write a description and save it. And then they get a little message here, drag report. And so they can take, for instance, the savings and risk trend report, drag it into the new folder, and then immediately over here, this popped in, which is your new folder, and whatever you want to, you can drag any arbitrary number of reports into it. And so now we need to exit, and we need to also look at the info. So this would be the description that was part of when we say the folder name. Because of the MouseFlow API calls that are being made as you go through this, it popped up a survey, and I can say, how would you rate the ease of use of this feature on 1 to 7, very difficult, 1 very easy, and I'm going to say, oh, it's about a 2. And then I can close that, and I'm pretty much done. So let's start out by looking at the prototype environment. The prototype is hosted in the cloud, but it can be run anywhere. It could be run inside the firewall. It's just HTML, CSS, and JavaScript. But we're going to host it on Axure, and you can see some of the screens here. And if we go into the advanced area, we can see that there's plugins for this prototype. And if we look at the plugins, we can see the include code. So this is going to load the API interface for MouseFlow, and this one is going to load the API interface for Piwik, which is the repository. So between these two interfaces, we can do capture, we can do surveys, questionnaires, we can push custom events into the repository for later use. So now let's go look at the MouseFlow part of it first. This is a screen full of captures that we've taken with MouseFlow using the JavaScript API and the MouseFlow capture code. And each one of these is a capture session. So let's look at the most recent one, which we just ran. You're going to see that this captured the whole session. So even like when I was talking about, giving the instructions. So let's skip past that and see if we can find where I actually start running it. Okay, so here I'm clicking through. This is a double time. Here's where I type it in. It obfuscates the input, although that's a setting that can be changed. And here I'm doing the drag. And here I'm looking at the new folder and closing it and doing my psychometrics. And there we go. And we're done with this session. Mouse flow is great. You can do a lot of very detailed analysis and heat maps, and it's a very broad, deep system. So now let's look at where that data actually went besides mouse flow. It went to Piwik, which is a big, mature, partly open source and partly paid service that captures and does analytics on usability data. So if we go into the reporting section and look at, let's actually look at the debugger, because this is the very latest stuff, and you can see this is a record right here. This is today's date and time, and you can see in chronological order the actual JavaScript calls. So every button click, every mouse drag, everything done in the UI is sent as a custom event from Axure to this repository. So you can see button 1, button 2, an icon click, and I think there's a drag here, and basically just 7 sort of events in a completed task. So any of the data from this repository can be exported, and when it's exported in CSV form, it looks like this. There's a lot of user agent stuff in the left-hand side: a session ID, event ID, IP, the normal stuff you'd expect from web reporting, IP address, browser, operating system, screen resolution. But then when you get further into the table, there's the custom stuff. And one of the key things is this cookie ID, which is essentially a session ID. You can see there's 7 events that end in C9CA, and those correspond to the custom JavaScript events that Axure pushed into the repo. So we've got the custom event name that tells what happened. And we also have a timestamp right here. And this timestamp was actually generated by the client. It's not dependent on any of the testing infrastructure, and it's just pushed with JavaScript here. And then from this raw log, we can do formulas and roll this stuff up. So that C9CA set of events in one session got rolled into a unique record with the minimum. So it grabs the minimum timestamp and the maximum timestamp in that session and calculates the difference. So this gives us a time on task metric, and then this counts the clicks in that session, and if there's not 7, it flags it as not complete. So this gives us complete and not complete, and then here's the Likert results from the survey. And there's also can be a little A/B testing, which is also done on the client side and just pushed here for analysis. We looked at how the clicks get captured, but we can also look at how the A/B testing works on the client side strictly. So when the user comes in and adds a folder and starts to name it, this click right here creates a random number between 0 and 1 and does the A/B calculation on that. So we're just using the color of this alert as the A/B test, and there have been even more subtle things that made big changes in usability. So let's reload this. Let's just see if the randomization is working. Let's reload it, go back in, save it, and it's yellow. Reload it, go back in, save it, and it's red. And essentially, it's like flipping a coin for the A/B test. And to see how that works behind the scenes, here inside Axure, there's the save button you're clicking, and you can see over on the right, there's some JavaScript that does the UI work, hides the dialog, and shows the alert. But right here you can see that it's doing creating a random variable. And then the conditional logic down here essentially says that if the value of that random number is greater than 0.5, show the red alert. If not above, you do the yellow. So very simple, straightforward randomization taking place strictly on the client side. So we got our data, we got it into Excel, we crunched it down into one record per user session, and now we get to use some of the wonderful small-scale statistical methods from Sauro and Lewis. And they have this in-depth textbook on all the methodologies, but they also have a companion for Excel and R, and as part of this companion, they provide R functions that basically support all the methodologies in their system. And they also have tools on their website that do similar things. Let's look at how it works in R. I've moved some of the task times, a set of 28 task times for an A test and a B test, and the Likert ratings and the completion, and move them all in as variables in R. But let's first fire up the functions, and to do that, we're just going to find the file. It's called quant.ux functions, and we're just going to source that into R. So it's called quant.ux functions.r. Run that. Didn't like that. Minor detail. It's a string, and so we'll run it, and here they are over on the right. And if you click into any of these, you can actually see the R code that they're providing. Now what I've done is gone through the textbook and just use a lot of the examples there to support my usability test case. So I have this time on task from the prototype that we just saw, just to cherry pick some of what can take place here. Let's actually run all this, set all these variables. So now we have task time is set to this vector, and it has a mean of 57, and then the second one has a mean of 52, and they both have a length of 28. We can run these in just so we have them in the environment, and we can actually run these in, why not? So now we can play with some of these functions. One of the first ones is a confidence interval, and since we have over 25 roughly, we have 28, we can use this median-based confidence interval. So we'll run in the centrality and length, and then try out this function with a 95%, and that gets us a median of 54.26, upper 63, lower 46, which sounds pretty good because our benchmark that was, these are in seconds, we expected users to finish somewhere around 60 seconds would be good. So if that was a smaller sample, there's a function here for doing it with log and geometric mean. We also have a function to compare our task time a vector to the benchmark. So if we run that, this is done with a log conversion because of the skewing of the time task data, and we see our median again, the 54.26, geometric mean, and the probability of exceeding is pretty low, 0.05, and the probability of being below, which is good in this case, lower task times, is 0.94. In addition to the looking at the probabilities around the benchmark, we can look at a A/B comparison for the two task times vectors that we had. And to understand that, maybe we can look at their means. Like first set of task times had a mean of 57, this and a standard deviation of 15. The second one had a 52 mean, which is less, and a very close to the same variance. So the question is this difference between 52 and 57 significant? So there's a nice function to look at that. It's an independent t-test. We'll pass it both sets of times and run that. And what we get is that the difference is around 4.58, and the confidence interval around that goes down to -3 and up to 13. And so that's straddling 0. That might not be a significant difference between those two. But let's look at all these things in visualizations, and that will help. Like starting with maybe a box plot, which looks like that, and these are time on task numbers, so they tend to be positively skewed, which you can see here by the longer tail. If we compare the mean and median, that also supports the fact that the mean is larger than the median, so that supports the positive skew. We can actually look at the skewness number, which is 60. If it's over 0.5 to 1.0, it's a moderate positive skew, which is what we see here. We can also run a histogram, which looks like that. And you can see the 60 is pretty much sitting in the middle of the normal distribution, and then here's the density plot for the time on task, and with that right-hand skew. And maybe just one more. Here's a dot plot showing the confidence intervals. Load that library, and now run this, and the dot plot looks like this. And I think this supports what came out of those functions, 43 and 60, or maybe 46 and 63. And if we go back and look at what these confidence here, there's sort of some correlation there. We see the 46 there, the 63 there. And then finally we can look at plot for the A/B test, which we can do a simple one, I think, that looks like this. So we see that difference between the means less than 5, and then we see the straddling confidence intervals. And I think I did one more view of this that has the distribution, and that looks like this. So there's the density plot of the difference between the means, the sampling distribution, and you see 0 here, and the lower and the upper. So that sort of confirms what we got when we ran the magic function. And that's about it. Going back to our framework here, we ran the prototype in Axure, pushed JavaScript into both MouseFlow for the screen capture, and into Excel, and finally into R, and took advantage of the amazing, comprehensive, and skillfully organized user testing framework from Dr. Sauro and Dr. Lewis. And I guess it would be good to put this in perspective. The early stage usability testing is right at the heart and core of the overall design cycle, and all these things feed each other. The really early research feeds into some early screen design, and then that can feed this testing cycle where you get really detailed feedback on functional designs, and then that outputs a problem matrix where things can be fixed and further discussed and further researched, and it all goes round and around in a beautiful spiral and comes out with a viable solution. Thanks for listening.